Hi, hello everyone. Welcome back to my class videos, Biology for Engineers. 21 BE 45 that I am covering chapter 4, starting chapter 4. Okay, after a long gap, covering chapter 4, starting chapter 4, that is module 4. Okay, so module 3 or module 3 notes, videos, everything covered. Even module 1, the course outcome based revised Bloom's taxonomy level based questions and answers discussion also started. So just started that with the materials are available with me. So I got a time, great time to put a video, record a video. I'm recording this one right now. That is fourth chapter, fourth module, first point, that is ecolocation. Okay, the title of this chapter, that is nature bio-inspired materials and mechanisms. Okay, not only few, majority of the items that we use, materials that we use, technology that we use, that we have got inspired from the nature by seeing how the things, how the bird flies, aeroplane comes, how the so many things. Okay, I'm not going that biomimetic part. Still, it is there in the next module. So there we'll see in detail. So these are naturally inspired or natural or bio-inspired materials and mechanisms. One such is echolocation. It's a biological or a technological process, that echolocation, which involves emitting sound waves and listening to the echoes which bounce back off the sub object in the environment, and we can determine the exact location, the distance from us, as well as the shape of that. Can identify that. Biology as well as technology. Biology, it was early there, then we copied it, and the technology also we have echolocation. So in biology, the use of echolocation by animals, it has been well documented for centuries. Like ancient Greeks, they observed bats using echolocation to navigate and find food in the dark. The scientific study of echolocation in animals, however, only began in early 20th century by British naturalist Donald Griffin. So Griffin's research showed that bat uses echolocation to navigate and even hunt, and it helped lay the foundation for the modern study of echolocation. Technology, the use of echolocation was used mainly by the submarines during the warfare, mainly during the World War One. British Navy, they developed a primitive form of sonar which they call as ASDIC to detect the other submarines. So a comparison of echolocation, biology as well as technology based echolocation, it is given below. Biological echolocation, it is found in various animals like bat, dolphins, some whales. They rely on emission of sound waves. They produce sound waves or click sounds. Mainly the dolphins make, even whales, they create this type of click sound in the water. Okay, the emitted sound, animals emit sound waves and listen for the echoes produced when the sound waves bounce off objects in their environment. By analyzing the echoes, animals can determine the location, distance, and even the shape of objects around them. The ability is mainly used for navigation, hunting, and communication in the animal kingdom. Biological echolocation is a natural adaptation that has evolved over millions of years. So nothing so complicated. These things we already know. So it is already included. So that it's just included. So no need of a brainstorming session for this. This simple thing that we already know. So how technology echolocation, that also we know. Okay, so comparing it, just comparing. Okay, so uh, technical equation, it also uses sources like sonar, ultrasonic, ultrasounds, the emitter sound, and the received receiver will receive the sound, and we have engineers, human engineered the solution inspired by the natural ability of animals. The principle behind echolocation, the same thing. Okay, so you can see how the reflecting sound wave is produced, and it echo is collected. So both biological and technological echolocation, it rely on the same basic principle. having to identify the location or distance measurement or shape, identifying the shape. Okay, the principal accuracy is based on emission of sound waves and interpretation of echoes that bounce back. Okay, so general, if you say we have to write in detail, sound emission. Sound emission is done. Propagation of sound waves. The sound waves passes through the medium. Which medium? Depending upon the medium, the effect will be different. Then object interaction. The sound wave go and interact with the object. Echo or reception. Some of the sound waves interact with the object, bounce back or echo of them. These echoes carry information about the object's distance, shape, and composition. Sensory reception, the separate sensor will receive these echoes and echo interpretation. Then interpretation will be done based on the distance, how much time taken by the sound wave to reach to the location, coming back, all those. And if it is moving body, then it has to be calculated accordingly. So those calculation, mathematical calculation, will be done by the instrument or the computer, and will get the result. Okay, so if comparing with the biological and the technological ecosystem with the sound emission and the reception, sensory reception, in biological system, the bat as well as the octacean, they produce a specialized sound emission organ to produce sound for the echolocation. In technological, it depends upon a device which makes the sound, a speaker or a transducer to generate a sound waves so for echolocation. Bats will emit sound with their organ called larynx, and modify the emitter sound using structures like the nose, leaf, or mouth cavity. They control that emitting sound. Dolphins and whales emit sound through the blowholes, producing the click sounds or vocalizations. Okay, so ultrasonic sensor or sonar system emit sound wave through these devices, typically using piezoelectric element or a transducer. The receiving biological organism, they have a special sensory reception organ which allow to detect the interpreting the returning echoes. Bats have ears. Dolphins and whales have echo receivers in their jaws. Whereas a technological system, we have separate sensors to receive the echoes and analyze it. History of technological echolocation. It can be tracked back to early development of sonar, sound navigation, and ranging. That is a full form of sonar. SO stands for sound. SO. N represents navigation. A represent and R represents ranging. Okay, so sound navigation and ranging technology. Okay, so a concise history is given here. Called as early sonar development, late 19th century. Foundations of technology echolocation were laid with the invention of the first practical underwater sound detection device called hydrophone. Hydrophone images are available in Google. I didn't put here because that's very old one. It was developed by regional Fessenden in the late 19th century. The hydrophone allowed for the detection of underwater sounds. During the 20th century, the World War One, they needed this technology to identify the presence of submarines. Then during mid 20th century, a continued advancement in sonar technology is seen for military and scientific research. They are refined and improved for applications such as submarine detection, underwater mapping, and marine research. In the mid 20th century, that is ultrasonic application. Parallel to the underwater sonar, ultrasonic technology also began to find application. So sonar means that is underwater, ultrasonic that is normal, not underwater. Okay. Uh, Sonar application, mainly the term it is used for water in the submarine detection and other destruction or other object detection in water bodies. Evolution of echolocation technologies started late 20th century and present. More sophisticated echolocation system were emerged. High accuracies is there. They are used in robotics, autonomous vehicles, healthcare, environmental monitoring, etc. Ultrasonography. What is ultrasonography? That you might have seen this type of probes the doctors use to check our body any damage or the live streaming. Okay, live streaming of our body biological system. Okay, how it does it work? It again send the sound and receive the sound, and a clock is used to measure the time taken to send and receive. The time gain compensation takes place, amplifies the set and convert into the form of an image. So you can see in the monitor we can see our kidney or any organ which is working. Okay, so it is a medical imaging technique which uses high frequency sound waves to produce images of the internal organs and tissue of the body, known as ultrasound imaging or sonography. Also. Okay, the ultrasound machine emits high frequency sound waves in the range of 2 to 18 megahertz, which travels through our body and thick objects wherever it touches it rebounds, and based on the thickness of the tissue or thickness of the organ, distance of the organ will get the image. So it is a non-invasive, safe and painless imaging method. It can be used for visualize a wide range of structures within the body, including the organs of abdomen, pelvis, chest, as well as uterus, fetus, and other soft tissues. Uses, it is used in what is that, obstetrics and gynecology. These are the terms used by doctors. It is used in abdominal imaging. It is used in muscular skeletal imaging, vascular imaging, eye and neck imaging, emergency medicine. Okay. First one, that is commonly used to monitor the growth and development of a fetus during pregnancy. Okay, pregnant women they use it. Not pregnant women use. The doctors use to analyze to check the growth of the child. If any deficiencies are there, so that it can be treated. Ultrasonic abdominal imaging, abdomen such as liver, gallbladder, pancreas, spleen, kidneys. Okay, these are the terms that we know we heard. Okay, so to check it and if any diseases there, kidney stone etc. can be identified very easily. What musculoskeletal imaging, uh, to to image the muscles, tendons and ligaments to diagnose conditions such as any muscle strain is there or ligament sprain etc. If it is there, it can be identified very easily. Ultrasonic vascular imaging to blood vessels, arteries, veins, all can also be identified. Eyes as well as neck can be diagnosed, like cataracts. Okay, cataract. This is the starting of cataract that I am wearing a glass. Okay, they can check what is the level of cataract. Glaucoma and thyroid nodules can be identified. So overall, I don't want to delete it. Okay, working principle of ultrasonography. The working principle of ultrasonography, it is based on reflection of high frequency sound waves. It has got a transducer. It has got a which emits the sound from 2 to 18. Reflection of sound waves takes place if echoes are received and converted into image. Okay, already explained. Again, as a note, it is given the advantages of ultrasonography. It is very non-invasive method. Non-invasive method, it will not create any cut wound. Non-ionizing radiation. The ultrasounds are not such ionizing radiation. It will not kill the cells. That is the meaning of non-ionizing radiation. Real-time imaging. We can see the images, moving images or working images. No need to give sedation and all. You can just pass through that and you can check, pass through our body and check how our organ system is working. Okay, so it is very portable. Uh, it can be carried for emergency and rural medical medication and cost effective. Okay, compared to many other costly one, these are cost effective. Versatile, they are versatile. Yeah, images are so easy to identify any changes in the organs like abdomen, pelvis, chest, uterus, fetus, and other soft tissues. It can be limitation. It has got some limitation like a depth. It cannot penetrate to through the bones. It cannot penetrate through gas. Dependence. It depends heavily on the skills and experience of operator. Okay, the doctor, whether he is specialized in ultrasonography or not, or a person specialized person, so it gives a better results, or different people they use, they will give differently, they will use, and we'll get confused. Okay, limited resolution. Ultrasonic, it has got limited resolution compared to other imaging methods. So the images are not that much clear, like just like our ultra high quality images. Simple images we are getting, not images, living images. Limit in overweight patient. If too much fat is there, too much overweight is there, in that patients we are not getting the it causes that limited depth issue only. Okay, so I think you understood it. Limitations in detecting some types of cancer. It is not able to identify some type of cancer such as the pancreatic cancer, because it is not producing any characteristic signal, so characteristic echoes based on that. That's therefore these are the limitations. Sonars. Sonar, that is sound navigation and ranging technology, mainly used by the ship or submarines to identify the depth of the water, even other ship coming, the submarine presence, any ice, any object in the path identification, and that sonar is used. Naval application also it is used. Fishing applications. Oceanography to study the physical and biological properties of ocean, it is used. Environmental monitoring also it is used. It works by a series of sound calls and listening to the echo. Same working principle is the same as that of ultrasonography. It has got a transmitter. It has got a. It will propagate the sounds. It receives. It calculates the range, determines the target properties, and display the result. Advantages like sonar technology is also very versatile. It's very cost effective compared to costly items. They are non-invasive. They won't create any cut wound. Okay, it can be used such as diving remote operated vehicles. It does not physically disturb the underwater environment. Not, but it disturbs. Not, you cannot say so. It will not disturb as such. It's one of the limitation also. Real-time imaging, high resolution is there. So sonar technology has got limitation like limited visibility, interferences. It interferes with other signals which are passing through that, and a wrong result we may get. Short range, it will work for a short range. It has got a limited depth. Okay, it has got acoustic noise. This one not is. This noise, the sound, the disturbance, it disturbs the marine life as well as the marine ecosystem. It's a complex technology, inaccurate in reading, not so accurate as. So that about the chapter 4 or module 4 topic 1. Module 4 topic 1, how we are inspired from the nature or biosystem and the mechanism, materials and mechanism. One of that one is ecolocation. Hope you have understood this. Thank you very much for watching my YouTube channel. Please do subscribe. Share this video to many. Soon I'll be posting the PDF note link to the description box. Till then you have to wait. Thank you very much.